All right, for some reason things got cut off. But what I was saying is if you set this equal to this and they get the same decimal, then you're good to go. This will also give you the same decimal, so you have to be a little bit careful. Okay, I want to jump over to this one here, and we're going to tree, and tree, and then see if we can put them together. We can't put them together because right now the exponents are different, okay? So let me do it on, I guess I can just do it really small. So 27, 3, 9, 3, 3, 3, 1, okay? And then I list my x's. 1, 2, 3, 4, 5, 6. And I'm going to come over here and I'm going to 12, 2, 6, 2, 3, 3, 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I'm going to start circling some doubles here. So I'll circle this double, this double, this double, and this double. So that gives me 3x cubed, and then square root of 3. So that's what goes on the inside. Can't see that, sorry about that. And then subtract, circle my doubles. Oops. 1, 2, 3, 4, 5, 6, 7. Yes, some of you are noticing a pattern. Yay, you should. If you don't worry about it. There's nothing wrong with circling doubles. Square root of, what's the only thing I got left? 3. So now, these look like the same square roots, but the problem is these exponents aren't the same, okay? So if you had, I should have made that question better. So this would be the final answer. But let's say it was 3x cubed rad 3 minus 2x cubed rad 3. Then the answer would be 1x cubed rad 3 because they would be, they would be exactly the same. So the exponents are different. You can't put things together unless you multiply. Only when you multiply can you put anything you want together. But when you're adding or subtracting, you can't. You have to be picky about it. Okay? So if these were the same, you could subtract them. All right. Let's go down to this one. There's different ways to do this. One way is to distribute the -5. But I don't like that because I don't like negative exponents. So I'm going to take this and move this entire thing downstairs. The problem is, though, that still stays negative because all I did, let me unblurry that, is this negative I turned positive, okay? So now I would distribute. I would then get 1 over 2 to the 5th power. Sorry, it's so blurry, I can't fix it. Oh, there we go. 2 to the 5th, which means 2 times 2 times 2 times 2 times 2, 2, 4, 8, 16, 32, a to the 5th, b to the 40th, because remember we multiply, and then c to the -10th. Now I don't like this negative, so I got to move this up there. So it becomes c to the 10th over 32, a to the 5th, b to the 40th. Okay? All right. I figure you want me to do this next one because there's a whole lot of fractions. Okay. So I got a 6, so that's not my problem. All right, I got a quarter, I got $2, I got a quarter, and I got another quarter. So I want you to think about this. So I got 25 cents, I got $2, I got 50 cents, and I got another quarter. How much money do I really have right now? Let's see, 225, 275, I got $3. Yeah, it's that simple. Okay? Some of you go, but how do I do it if I don't know it's money? I go 1/4 plus 1/2 plus 1/4, common denominator times 2 times 2. So that's 2 over 4. 2, 3, 4 over 4 is 1, and 1 plus 2 is 3. Sometimes things that seem scary aren't really scary. Yeah, some of you might still think it's scary. Sorry, can't win them all. All right, in each of these, I want you to state the vertex. And I want you to graph the parent function and the original. So x cubed, I will do my parent in yellow. I know is a squiggle. Not the cutest squiggle in the world, but it works. And then if my new function is left 5 and down 1, yes, I need to label. It's still a squiggle. It just moved to the left and moved up 1. Horizontal translation, 5 units left. Hey, that's what happened. Vertical translation, 1 unit down. Hey, that's what happened. All right, this one, let's do the vertex. Okay, this is a confusing one. I don't like lines very much because the lines are not easy to see, the transformations or the vertex. Okay, so if I was to graph this parent, I'm faking it a little bit. This one, we would go down 1, but it's going to be vertically stretched by a factor of 8. And some of you, can't I just go up 8 and right 1? Yeah. Doesn't that look vertically stretched? If I vertically stretch it, it looks taller now. All right, let's do this one right here. This, I know, this is the one you struggle with the most, and I haven't tested you on it because I know you struggle with it, okay? So, the vertex, do the opposite, nothing on the outside. The difference is this one, it has areas where it's not going to touch. You notice how it didn't cross there? So that means now at -2, it's not going to cross there. But it's also going to have a reflection. So instead of being here and here, it's actually going to be here and here. You don't have to be good at that one yet. You just kind of want to get an idea, okay? You can do the rest. This one, you know how to do that. You can work backwards from x-intercepts. Keep in mind, this can get you straight to this. When you multiply this out, it gets you to this. And you can find the vertex by going in the middle of the x-intercepts, okay? All right, I want to go over this one. I don't know if you guys remember all that complementary, supplementary, alternate interior, same side interior, same side exterior stuff, okay? So they want to know about, let's do angle 1 and angle 4. Do you remember what they're called? Okay, so they're called vertical. Vertical are the ones when you make an X. These two are congruent, and they're congruent, okay? What about angle 1 and angle 7? Okay, they're literally on the same side, but they're on the outside. So same side exterior. Do you think they're exactly the same? Well, they're not even in the same spot. So they are not congruent. When you add them, they equal 180. So we'll say they're supplementary. Remember, that means it adds to 180. Okay? Missing sides and angles. Okay, so I've got to figure out, what do you want to figure out first? Ooh, well, I can do this one. See if you guys remember how to do that. How many degrees are in a triangle? 180. If this is 90, this plus this is 90. So 90 minus 62, 28 degrees. Make sure you put the degrees or you will not get full credit. Let's say you wanted to find side C. Which one is side C? The one that, see how this is like this? That is side C. Okay, so I'll do C and you'll do A. So, okay, you have to decide, do you want to use the 62 degrees or the 25? Yeah, let's use the 62, okay? So if I use the 62, this is opposite and this is hypotenuse. That means I know if it's opposite hypotenuse, it's sine. Opposite hypotenuse. We all do it different ways. This is how I do it because I don't like fractions. I multiply both sides by C, because that gets rid of it. Now divide by sine 62. And then whatever you get here goes there. Now you're going to do A yourself. Okay, let's go to the next page. This is a circle. Yeah, you guys can do circles. This is, you need to practice this. Find the 2 points of intersection. I'll do this one, okay? This one's kind of hard. So this one's different because this one, you're probably hopefully going to take this and plug it in there. And then that's solved by substitution and get the answer. But this one, we got so many squares going on that it's crazy town. But what I want you to see is what happens if I add these two. That's gone. And then I'm left with 4x squared equals 36. You guys know how to solve this. Divide by 4. X squared equals 9. What do I do now? Square root. You're going to notice that a lot of, quote, simple Algebra 1 things that you do are applicable, but we might not always see them. Okay? That's why we practice. That means one of my x values is 3, and the other one is -3. Now, I'll plug this in. Pick which one. I don't care. I'll pick the first one because I don't like negatives. So 3 squared, 2y squared equals 11. That's 9 minus 9 is 2. Y squared equals 1. Square root, square root. Oh, so that means this is really 3, 1 and 3, -1. Do the same thing for -3. -3 squared plus 2y squared equals 11. -3 squared is 9. Subtract 9. That's 2. Divide by 2. Square root, square root. Oh, that means there's one with 1 and one with -1. And some of you go, wait a minute, how is that possible? Well, you don't know this, but this first one is a circle, okay? But this other one that you haven't learned is going to be a different shape, and so by doing that, it's going to cross 4 times, okay? So it's kind of like this and like this. I'm making it up, okay? I wanted you to get the idea. Find the points of intersection. Ooh, this one's a mean one as well. In this one, look what I notice is the same. This and this. So what I could do then is I could move this over. Or actually, you know what? Well, do I want to solve it by algebra or do I want to just graph it? I feel like if I just straight graphed it, which is probably why I got a graph, that'd be easier. So what shape is this? This is a U. So use your information about vertexes or vertices. And this is x squared and y squared, which means it's a circle. Use your center, use your radius, find the points of intersection. Okay? And you can always use Desmos to help you. But these are good questions. Okay? The last page. This kind of question is exactly like this type of question here. So I want you to practice that one. Okay. And then this is good because this is applicable like the first page. Creating equations from graphs. I'll help you with these because these are more difficult. Y equals, Y equals, Y equals. Look at me helping out. Y equals, Y equals, Y equals. Okay. So one thing you got to know first is that when you see the shape, square root of x. When you see the shape, x cubed. This one, absolute value. Absolute value makes a v. The cubic I remember because 1, 2, 3. Okay. And then when you do this, it kind of looks like this, doesn't it? Okay. This is the weird one, so I remember it because it's weird. This is, oops. This is a line, and this is a square. Okay, so what has all the power? What has all the power? The vertex. The vertex. The vertex. The vertex. The vertex isn't as easy to find on a line, so we'll just go with it, okay? And the vertex. So I just need to find it. We'll work on that one. Okay, so this is 0, -2. This is -5, -2. And I don't have my glasses on, so I could definitely be making a mistake. 1, -3. Wait, 2. Looks like 5, 2. I could be wrong here. And then this one is, I don't know, 3, 1, 2, 3, 4, 5. 3, 5. Okay. So I just got to make this look similar. So let's zoom in and do one at a time. All right. Nothing with the x, the y. If it's with the x, not a straight shooter. Got to keep that cube. Straight shooter. With the x, not a straight shooter. Not with the x, straight shooter. With the x, not a straight shooter. Not with x, straight shooter. with the x, or not a straight shooter, straight shooter. Okay. And the last one, it's probably just easier for you to do slope, which is negative 2x plus 5. Okay. Another way to do this one is do point slope form, which is y minus y1 equals mx minus x1. And that technically puts it in vertex form, but it'd probably just be easier to do that. All right, you'll be doing the rest. Thanks.